Welcome everybody again. Welcome to today's Westgate Expert session. Today's topic is all about working with semi-structured data. So before we start, a few words about me. I'm Julian. I'm a senior BI consultant here at Scalfree. I basically started my career in more or less business analytics and data science. And afterwards, I joined Scalfree about 4 years ago. And since then, I have been helping clients implementing BI solutions, of course, with Data Vault 2.0. And this ranges from high-level consulting to the technical implementation. Okay, so again, today's topic is how to basically model semi-structured data in Data Vault. We received one question. It's basically about whether storing the files as they come or flatten the structure beforehand. Short answer is, as always, it depends. So there's no best solution for every case, but I want to share some thoughts and share what to consider before you start integrating this kind of data. So first of all, be sure about the expected data structure. So firstly, let me show you an example. So semi-structured data is great to deliver information because of its flexibility. For example, in streaming services, it is often used. But at the same time, this flexibility is often hard to handle because the schema is not static. So every object in one file might have another schema, or the schema changes in the following files. Or you could even have a nested structure, basically a hierarchy, which is an object inside an object with own attributes. So there are multiple things to consider when loading your Data Vault. In this example here, we have country information, basically, two countries, Germany and France, with an ISO code as business key and the telephone code, for example, population, currency, continent, and some other metadata information about the file. So that's the first file. And when we have a look in another file, then you can see that the structure changed. So for example, for the next file, we have an additional attribute, which is the time zone, which is an object by itself, right? So we have kind of a nested structure here. So having this in mind, let's jump back to the considerations. So as I said, be sure about the expected data structure. So frequently changing structures are hard to handle when you store the data in a relational format in the first place. So you probably got a lot of null values or missing columns if you don't adapt the relational structure in advance. And the structure of for example, JSON file can be very complicated due to the possibility to build hierarchies, as we just have seen in the example. So do you have nested objects? Is it sufficient to flatten only the first hierarchy? To what extent do you have to flatten the structure, basically to get the information you need? Then velocity. Do you have a lot of messages that have to process in real time or near real time in case of streamings, for example? Then the size of the files is important. Is it necessary maybe to split the files? This also refers to database capabilities. For example, on Snowflake, you would store the data or the file in a variant column, which has a limit of 16 megabytes. What if the data exceeds the limitations? So check if it's possible to split the files. In some cases, the file is composed of a single huge array containing multiple records. So you could for example, remove the outer array structure and load the records into separate table rows. Speaking about database capabilities, how is the performance, is the query performance of your database regarding parsing and flattening files? If it's slow, it might be a better choice to choose a relational structure for your data vault. Otherwise, you would have long running queries when you want to get the data out. If you know your use cases or operations you want to perform, simply test it with a typical data set. If you don't know which kind of operation you need to perform on your data, it might be better to store the files as they are. So that's some recommendation or considerations that came up on my side. So if I missed some important points from your perspective, feel free to shoot them into the chat. So I would like to sum it up a bit. So comparing basically store the data or the files as they are, what would mean what will result in just having one column basically, and compared to the second option to flatten the nested structure. So pros for storing the data as it is it's really fast to get the data in, and you can handle changing structures really easily, because you basically don't care about changing structure. You simply store those files in one column. And as I said, if operations are unknown, it would be basically easier to just store the data in one column. The negative aspect is that there might be limitations if you receive big files, and of course it's harder to query semi-structured data compared to relational structure, right? So flattening the nested structure, again, it's faster, of course, faster to get the data out, because most databases are faster when querying relational structures compared to hierarchies, for example, and it's therefore a lot easier, and there are no file size limitations. The negative aspects here are that you have a fixed data structure, so you have to adapt your relational structure in case of any schema changes, for example, and it's therefore harder to handle nested objects. Regarding data vault modeling, if you decide to store the files as they come, I would recommend to use a kind of a non-historized link or non-historized satellite, basically a standard structure. Those metadata information as hash keys, record source, load attempts, and of course, but just one column for the whole file. So in case of real-time messages, you would use those non-historized links, and you could use, for example, the message ID or event ID as a unique key, which serves as the input for the hash function. Or you could use a hub and satellite combination, and where you're gonna extract the business key from the file and store the file itself in a satellite. If the file contains an array of objects, think about to split the file and load the objects into separate rows. And after you stored the files, or you basically modeled your raw data vault, for example, with a non-historized link, you can build data vault structures on top that are virtualized in the best case. So those data vault entities on top are in a relational format, which makes it easier for end users to query the data. And there's still the physical table with the file, but all they see is a view with a relational structure. Second option is flattening the structure before loading the raw data vault. Here you, of course, need to identify the business keys and possible relationships inside your source data, but that's as always, right? So after it, modeling is quite straightforward because you would use just standard data vault entities. But in this case, I would additionally store the files somewhere to not lose any data in case of unexpected schema changes. So, for example, in a data lake, or in an additional column in a satellite, for example. Okay. How to process CB structured data within WhereScape. So WhereScape has an enablement pack for it. So let me jump to the WhereScape website. So here you have under data solutions, you have the enablement packs where you're gonna search for the source enablement packs. And here we have got the file parser. And the file parser enablement pack supports different data formats such as Parquet, JSON, XML, CSV, and so on and so forth. And down here you have an installation guide and release notes, so you can easily install this package in your WhereScape application. And then after you installed the package, it's quite easy to browse through the semi-structured data. So what WhereScape offers is basically a browser and a load script. So you can browse the data inside WhereScape and set options for file parsing. For example, you can set the depths of the structure if you want to just query the basically the top level, or you want to go deeper into the hierarchies. So that's all possible with in the enablement pack. And afterwards, the data is loaded into load tables, and from there you can further process your data and load your data vault entities. That's it for basically today's session. Are there any questions? So let me check the chat. Okay, seems it's not the case. All right. So one note for the next session, the December session is canceled due to Christmas, to holiday. Basically, the schedule is, well, the next session is in January again. So we're gonna run this session every last Thursday of a month at 2 p.m. Central European time. All right. So if you're interested in the Data Vault community, you can scan this QR code and join the Data Vault innovators. On this platform, you can ask any kind of questions regarding Data Vault or any data related question basically. So feel free to join us here. All right. If you have further questions after this webinar, after this session, you can send them to events@scalefree.com, or if you need further information of one of our services, please contact sales@scalefree.com. All right. Hope to see you in one of our next sessions. Thanks for joining and have a good rest of the day. Bye bye.